classification model has been discussed, which falls under the supervised learning algorithms. But for the regression models, there are different scenarios. So in the classification models, we have seen there is mention of target variables for the y. But in the regression models, there is no mention of target variables. Based on our input features, we have to follow the linearity. So it deals with the multiple collinearity, as there are many input features. Based on these input features, we have to predict the output features. So as the right side of the image, you can see there are the increase or decrease of the stock prices in a certain amount of time. But if you want to find a limited time frame for suppose February 1, then what is the output level or predicted stock price can be average. So it mainly predicts the dependent variable based on the independent variables, and it has no target level features that I previously mentioned. There are many common algorithms for the regression models. Linear regression is one of the common, where the data points have been firstly distributed, and if we plot it in an XYZ plane and the line of regression has been plotted, and based on the calculation, the coefficient and residual plots, the data points has been calculated, and based on this, the y predict value we can predict based on our input features. So there are many use cases for the regression models: house price prediction, stock price forecast, or temperature prediction, and many others. So for unsupervised learning algorithms, clustering is one of the most common way to simplify our data. But as you can see, the right side of the image, the data has been distributed in a very globally. But if we follow the K-means clustering, the data has been clustered into very different centroids, and they follow different characteristics. As you can see, the images follow the different characteristics, and data has been clustered. So it iteratively assigns points to the nearest centroids and updating the centroids. Same for hierarchical structure, whether it follows a tree-based structure at the bottom-up or top-up approach. Where a density-based cluster is follows a core point mechanism, where the core point has follow and along with this neighbor it creates a dense, and if this another data points does not follow this core point, it and again initialize another core point and make it dense and with along its neighboring clusters. So, and also there's a factor of noise points. So there are many use cases of this clustering algorithms, and customer segmentation, image segmentation, or anomaly detection are the common use cases for clustering algorithms. Now for the dimensional reduction as better used for better computational efficiency and better simplified way, and capture the variance in a very 2D dimensional manner. In the right side of the picture, as you can see, the PC performance component analysis model has been used, and the data has been reduced in a 2D dimensional way. And it really helps us to visualize high dimensional data with preserved similarity in a very lower dimensional, and for better understanding what can be the anomaly or what can be the use cases of this unsupervised learning with the dimensional reduction. And for the feature selection is one of the most important aspect of the machine learning. In finding the correct relevant features, one of the most important aspects. There are many algorithms as filter algorithms, wrapper methods, or embedded methods. As you can see there, and in an example I can see, you can see there's all the features are being mentioned. For the random selection, the data has been randomly selected and then follows the training phase. For the filter selection, the greatest chi-square difference, or I can say the correlation metrics or correlation values are being assigned, and then the feature has been selected and follows the training phase. Whereas the wrapper selection follows the search space iteration, where the features are being divided into subsets and then follows a training step. And embedded methods, embedded selection, feature selection follows the same strategy with like lower computational efficiency. So this is the part I have covered from myself. Thank you.